So the review, it tests you on lots of different information, but this starts off with what we covered in section 2. 10.2 covered hypothesis and conclusion. The hypothesis is everything after the if. If I study for the test. If I study for the test, that is your hypothesis. Then lets you know that the conclusion is about to come. I will get a higher grade on the test. If this happens, then this should happen as well. That's kind of what a hypothesis and a conclusion are. So we underline a figure has 3 sides. The figure is a triangle is the conclusion for number 1.b. In the 2-column proof on number 2, what we're actually doing is we have to look at the statement. The very first reason is always given, and we have to figure out what the other person did between statement 1 and statement 2. So if I look, and I see that 5 multiplied to the x and 5 multiplied to the negative 2 and becomes 5x minus 10 plus 8 equals negative 3, then I know that they use the distributive property of equality. And then if it says combining like terms, I have to decide how can I combine like terms. I must put the negative 10, bless you, and the 8 together and get negative 2. Then when they add 2 to both sides and get the negative 1, they use the addition property of equality. And then they divided by 5 and got x is equal to negative 1 over 5. This is what you're trying to prove. Questions?
Do we have to write of equality at the end?
That's the proper way to write it. Would I mark you wrong? Probably not. But I prefer it. Junior? If you put negative 0.2, it'd be the same thing. It's the same thing, but I do fractions. It's easier that way for me. Anything else? Number 3. Number 3 was by far probably the hardest one that you've had because you had to develop your own 2-column proof. You had to put in what was on the left side and you had to put what's in on the right side. Some of you are not ready for that just yet. This is more of a Math 2 type of concept. But I like leaving it here because it's very, very basic. Okay? Don't forget, what's given to you is what you should start with. If I'm given the angle 1 is congruent to angle 2, that's your first statement, and your reason is that it is given to you. Angle 1 is congruent to angle 2. Now, everything after that needs to build. You need to prove that 3 is congruent to 4. Well, how can we do that? Here's what I did, and just because I did it this way doesn't mean you have to do it this way. You can do it in a different way if you want to, but this was the shortest way that I could come up with. First thing I said was 2 is congruent to 4. How do I know 2 is congruent to 4? I look at the picture, and then I realize 2 is congruent to 4 because they are vertical angles. I put vertical angles are congruent. I would also accept the definition of vertical angles because those are vertical angles and vertical angles are always congruent. Well, if 2 is congruent to 4, I also know that 1 is congruent to 3 because those are also vertical angles. I put here vertical angles are congruent, but you could also say the definition of vertical angles as well. And then here's what I look at. 1 is congruent to 2. 2 is congruent to 4, and 1 is congruent to 3. So I could say, since these are the same, and they're both equal to the same thing, then 3 is congruent to 4. I could say that by the transitive property of equality, because these are the same value. That was the shortest way I could come up with. Somebody asked me, do I have to fill in every single box when I do a 2-column proof? No, you do not. It's there in case you need the extra room. Turning the page. There's a whole mix of problems that will decide, do you know what to do when they're vertical? Do you know what to do when they're supplementary? Do you know what to do when they're complementary? So the key words on 4, 5, 6, and 7, vertical angles, they're the ones that are across from each other. So if I were you, I would draw a picture of vertical angles, and I write in that this is 2x plus 42, and I write in that this is 5x minus 3, and I know those are equal to each other. So you can find an x that will actually make them equal to each other. 15. That is not the angle's measurement. That's the value that will make this angle equal to that angle. When you plug 15 into both sides, it will make both angles the same. When I plug in 15 to this side, I get a number. When I plug in 15 to this side, I should get the same number, and I believe that I do. Vertical angles, I set them equal to each other. Supplementary angles are different. You don't set them equal to each other. The word supplementary means adds to 180 degrees. So if I'm adding to be 180 degrees, then I'm going to put 3x minus 7 plus the 2x plus 12 equals 180 because they're supplementary. And then I can find the x value by combining like terms. 3x plus 2x is 5x. Negative 7 plus 12 is negative 5. Did I do something wrong here? No, negative 7 plus 12 is positive 5, thank you. And then I subtract the 5, I get 175, and I divide, and I figure x is 35. That's not the angle's measurement. It says find angle y. That means plug that x back in so you can figure out how big that angle is. And you can use a calculator for that. Do 2 times 35 plus 12 to find angle z. And plug in 3 times 35 minus 7 to find angle y, and you'll find that those two angles are 98 and 82. Vertical angles you set equal to each other. Supplementary angles add up to 180. The word complementary, on the other hand, means adds to 90 degrees. So this angle plus this angle should equal 90. I wrote down 5x minus 3 plus 2x plus 30 equals 90. And then I combined like terms. I subtracted and found an x that would make them add to 90. And then I plug that x back in. I can't tell you how many students miss questions because they forget to plug the x back in. In all of these problems, you have to plug the x back in to find the angle's value. Vertical angles are equal. Supplementary adds to 180. Complementary adds to 90. And so, number 7, you have to come up with an equation first that is 5 times the measure of its supplement. When I think of that being added 180, I can draw a picture of two angles that add to be a straight line. If one angle B is 5 times the measure of its supplement angle A, then I have B and A here, and I said this is x, this is 5 times bigger than x. So 5x, and this is x, I add them up to equal 180. 5x plus x is equal to 6x equals 180. I know what x is, and I can figure out what both angles are. And you have to find the bigger angle. The bigger angle is 150. Looking at this whole chart, I really like it because you have to know a term and you have to know its definition. So if I'm looking at perpendicular bisector and I need a counterexample or conditional, like I need to be able to figure out what's the definition of perpendicular bisector. So I have to go over here and figure out that number 5, a line, segment, or ray that is perpendicular to the segment at its midpoint matches with perpendicular bisector. A is number 5. B, a counterexample is number 6, an example that shows a statement is incorrect. C, a conditional is number 1. It's conditional if it's an if-then statement. The hypothesis is everything that follows the if. That's number 8. The conclusion is the then part. The truth value, I don't remember if we wrote this one down or not, is number 9. One counterexample will prove a statement false. The truth value is it always true? What's its truth value? Is it always true? True or false, one example will prove a statement false. So I want you to know that for a truth value if I didn't talk about it already. I don't think that's a priority of mine, but just in case it shows up. G, what's the converse? The converse is an exchange in the hypothesis and conclusion. It's where you change the if and the then. Biconditional carries specific words. It carries the if and only if. If and only if. We can abbreviate that to IFF when you're writing out your own. Lastly, a good definition is I, and I is number 7. A good definition is good if it can be written as a biconditional. Keep that in mind. Those were those terms on that page. Then we go over to the next chart, and instead of just having the terms in words, they actually have some terms with some symbols. So when you look at reflexive property, you had to go to number 10 and say, oh, these are reflexive because they're the same thing on both sides. The symmetric property, on the other hand, is where you switch the order. A equals B, then B equals A. Or if AB equals CD, segment CD is congruent to segment AB. That's the symmetric property. On a side note, this is the symmetric property of equality because it has equal signs. And this is the symmetric property of congruence because it has congruent symbols, just in case I didn't tell you that. L, transitive property, is 16. Transitive, if you know the first thing is congruent to the second thing, and the second thing is congruent to the third thing, and then the first thing has to be the same thing as the third thing. That's how transitive property works. Substitution is where you replace that value somewhere in the expression. I like number 24, matches the best. The addition property is 13. It's where you add something to both sides of an equal sign. O is 12. 12 is if AB equals B, you can subtract C from both sides of the equal sign. P is number 21. The multiplication property, you multiply both sides. Q is number 11, where you divide both sides. Don't freak out if you see division and it's a fraction. Don't forget, fractions means you're dividing the same by the same thing on both sides. R. R is number 19, where this piece plus that piece equals the whole piece. The angle addition, on the other hand, is where you add two angles to equal the whole angle, like the 22. T, if segment AB is congruent to segment CD, if angle E is congruent to angle F. Let's take a look at T. T is 17. I came up with this one. If the segments are the same, then their lengths are also the same. If I know this angle is congruent to that angle, then the measures of their angles are also the same. There's a fancy name for that, and I forgot what worksheet it comes from. But basically, if you know these segments are congruent, then their lengths are congruent. If you know these angles are congruent, then their measures of their angles are going to be the same. That's all that means. Midpoint. U is number 14. The one that has the word midpoint in it. Keyword. Supplementary angles. Add to 180. I believe V is 20. It is. Complementary, as we talked about before, adds to 90. I believe that's 18. And vertical angles are the ones that are across from each other, which is 23. Almost done with the review. State whether the statement is true or false. If it's false, provide a counterexample. This goes back to section 2 again. I got false, false, true, false. If an animal is a dog, then it's a golden retriever. I put it could be a poodle. You can use any counterexample. All you have to have is one to prove that something's false. You could use any example you wanted to. You could use a beagle. You could use no, I can't say that one. Okay, you know the one that sounds like a bad word? That's what I was thinking of. And so, hey, see, it just sounds inappropriate, doesn't it? Yeah. And I'm recording, so I don't want to get in trouble for saying that one. All right, all segment bisectors are perpendicular bisectors. I put false, and I drew a picture. This is a segment bisector, and it went in at an angle. It could still cut it down the middle, if possible. There's a picture of it for you. If there are 3 congruent sides, the triangle is equilateral. That's true. If a triangle has 3 congruent sides, then the triangle is equilateral is what I wanted to put there. D, if angle A and angle B are complementary, then angle A is equal to angle B. And I put false because these can be complementary, but they're not equal to each other. That was my example. The last problem that I have for you is number 11, and it was on the back side. If they're vertical angles, you should know that they are equal to each other, just like we talked about before. I find an x that makes them equal, and once I find that x, that was the first part of the question, they always ask me LMD to plug it back in this chapter. Plug it back in to find the other angle as well. Well, they asked me for LMH. LMH. This is the one that's not even marked. So I plug it back in to find this angle, and the other angle, the one they asked me here, is the one that adds to 180. So I literally had to do 180 minus 30 degrees to figure out what that other angle was because it's supplementary. That's where I'm going to end that one.